Hello, good morning. We are Panther Pneumatics. I'm Felipe de la Cruz.
I'm Ryan Lucia.
I'm Milton Seoto, and right now you guys are probably thinking, wow, that's a cool name. It's interesting. So what is it all about? Okay, so what we're doing, we are combining two existing technologies. We're combining Pneumatic Ratchet, an impact range, and a Pass-Thru Socket. We want to do something small, powerful, and underground. Also make sure to meet the industry standards or maybe even increase it. Pneumatic Ratchet, this is an example of it. It's a really common mechanical shop tool. It works with small and medium fasteners. Average spikes 50 to 62 pound torque, 150 RPM, and 3 to 5 cubic feet per minute of compressed air. Next one, impact range, is another common shop tool. It works with large, medium to large fasteners. It has much more torque and RPM, 4 to 6 CFM compressed air. Now, the pass-through sockets. This is relatively new. It enables long bolts or studs to be extended through the socket and ratchet head. This is an example of it. It eliminates the needs for deep sockets. So we want to combine these three tools. Okay, we want to make something ergonomic, easy to use, high torque, high RPM, hopefully minimize air consumption, anti-lashback, something durable, and definitely something compatible with existing pass-through socket heads. Now I'm going to pass it on to Ryan.
Thank you, Luca. This is our proposed initial concept, and as you can see, it's very similar to the conventional air ratchet. We have our handle here with the turbine built in. This is our air inlet coupler, and this is the impact mechanism location. And this is the head, where we have our pass-through feature integrated. And as you can see, there's a hole straight through the socket, compared to your traditional sockets that can only do the certain depth that they're designed to do. And here's an exploded view of, this is actually a pneumatic ratchet, has the impact mechanism integrated. It does not have the pass-through head. So you can see all these internal components. This is the handle, this is the turbine broken down, this is our pin and clutch impact mechanism, and then our head design is here. And this is a close-up of some of those components. This is the air turbine, this is housing the rotor and the blades, which we're going to be using pretty much the same design here, maybe changing a few parameters to better our needs. This is an example of a pin and clutch impact mechanism. We chose this one for its small size and still great torque output. And this is the ratchet head, which we're going to be changing to enable the pass-through sockets. And just a few components here. This is the ratchet head, and this is the part that needs to be changed. It needs to have that pass-through hole, just like our pass-through ratchet here. And so here's our design tasks we're met with. We have to design a new pass-through head. The impact mechanism needs to be integrated. We're going to do material selection. We have steel, we have aluminum, and we have some composites that are going to be used in our design. And we want to make sure that they're hard and that they're durable for long use. These pneumatic tools are meant for very high cycle uses in mechanic shops and assembly industries. So we want to make sure that's perfectly met for those goals. And then we also have to do manufacturing processes to make the tool itself.
Okay, I'm going to talk to you about the global learning components of our product, specifically environmental impact, waste reduction, reduced power consumption, and increased user safety. As Milton previously stated, your standard pneumatic ratchet will use 4 to 6 cubic feet per minute at 90 psi. That's a fixed volumetric rate. What we're going to do by implementing the impact mechanism and restructuring the internal components, it's going to reduce the amount of time needed to unscrew each bolt, which over time is going to reduce the total air consumption. Also, obviously, air tools eliminates the need for battery or coiling tools, which reduces weight, chemical and electrical waste. Okay, so many people think that compressed air is inexpensive or a free type of energy, but a manufacturing company can use $30,000 a year just in electricity. This same company And that's to run a standard 1,000 cubic feet per minute air compressor. These are companies that use pneumatic tools a lot. The same company can waste 30% on average of their generated compressed air, which leads to $9,600 in lost profits. So what I'm trying to say is that a decrease in energy consumption will lead to an increase in overall profits. Safety, using your standard
Road safety is a very important
Yeah.
factor in our design. It's going to have anti-latchback features which prevents bruises, cuts.
the impact mechanism eliminates that behavior of the tool for it to continue to spin.
Any questions?
Are you guys gonna look for any sponsors?
At the moment, no. Our thoughts are to contact, there's a local manufacturer of air tools, Florida Pneumatics, located in West Palm Beach. And we plan on contacting them to see if we could set up a meeting with their engineers and see their manufacturing facilities. Maybe they can help us out with optimization of our design. But in terms of sponsors, the cost of our project is relatively low, so we're not concerned with expenses that might be needed. So, if you know of anybody, it'd be great.
If you're interested.
Well, this is more of a suggestion, just if you know about how long it'll take to put in the bolt with your design.
Yes.
Then you can kind of calculate how much time you're saving and put like statistics. Like, we're saving 25% time.
Perfect.
Every time you do a bolt.
Okay.
And then you can do an estimation, like I know that the Boeing 767, uses like, I think it's like a million bolts or something. So then you would say, if you're doing a plane and you're putting this many bolts, you're saving this many man hours.
Great, appreciate
So,
it.
and it would
Yeah,
just be a quick research job.
we're increasing the RPMs from about 150 to 400, so we're doubling it. So
Yes.
hopefully
so it
saving
would be
50% of
much
that
faster.
time.
And that looks really impressive, when you can put a statistic, we're saving this much time.
Sure, especially with the open design too, right? So, the open design also saves time.
Also, you don't have to touch them, you don't have to change tools, which also takes
Absolutely.
time.
Excellent, thank you.
The other quick one is just take a look again, I think we talked about it, so take a look again at just the requirements. There's a couple things, I don't know, maybe you didn't see, sometimes it's hard for help again, but just take a look and make sure that you guys check off each one of the little boxes that you're
Thank you. Any other questions?